Frequency is how often something occurs. A frequency distribution is a table of data points matched with how often it occurs. The letter grades received in a statistics class has the following frequency distribution. This shows that there are 5 possible letter grades, and 11 students received an A, 8 received a B, 5 received a C, 2 received a D, and 2 received an F. We can also figure out how many students there were in the class by summing up the total frequency. So there are 28 students in this class. In this example, our data was qualitative and ordinal. Let's try another example that's quantitative. The number of fouls in the last 11 soccer games has the following frequency distribution. Notice how 3 fouls is missing. If numbers were skipped, it's an implication that the frequency is 0, but sometimes it helps to fill in the gaps. If we read the chart, it says that 1 game had 0 fouls, 2 games had 1 foul, 4 games had 2 fouls, 0 games had 3 fouls, 3 games had 4 fouls, and 1 game had 5 fouls. Though the number of games was given in the question, we could also figure it out by adding up the frequencies. This was a discrete quantitative example. Now let's look at a continuous example. The weights of pennies were measured in grams. Notice how since the data is continuous, there are numerous variations in the weights. Dealing with the distribution table with this many rows is kind of ridiculous. So what we do is condense the information by making ranges of weights and consider the frequency of each given range. The first thing you want to do is think about how many different ranges you want. Instead of calling them ranges, let's call them classes. So there can be any number of classes, 2, 5, 10, however many you want. For this example, let's create 8 different classes. Now what we want to know is the spread of each class. We call this the class width. To find this, we take the largest data value and the lowest data value and divide it by the number of classes we want, which is 8. For us, the class width would be 0.09, but 0.09 is not the most convenient number. We have a base 10 number system, so it's more natural for us to count by tens. So rather than having 0.09 as our class width, let's make it 0.1. This is okay to do actually. We can round the class width to whatever number we want as long as we're always rounding upwards, never downwards. One thing to note is that if I round my class width up, it means that each one of these classes holds more numbers. Before we rounded our class width up, these boxes fit evenly into the space of our data points. But if the class width increases, our boxes will exceed the total range of our data points, meaning we can start to add numbers over here to be part of our group, even though their frequency is 0. So when we start making our frequency distribution, we can choose our lowest data point as our starting point, or some number in this space as our starting point. Since our lowest data value is 2.44, I'm going to round our starting point down to 2.40. It's a more convenient number that works well with our class width. Now we can start building our table. And the first thing you want to do is find the smallest number that belongs to each class. We call this the lower class limit. The lower class limits can be found by adding our class width to the starting point and to every lower class limit thereafter. The next thing we want to do is find the largest number in each class. We call this the upper class limit. To find the upper class limit, find the value just below the second lower class limit. Here, the second lower class limit is 2.5. The number just below it would then be 2.49. To find the rest of the upper class limits, just keep adding the class width to the previous upper class limit. Now all we have to do is fill in the frequency by looking at our data. The last thing we have to talk about is class boundaries. These are the values outside and between our classes. Let's look at how to find these. I like to start by finding the boundary between my first and second class. What I do is find the midpoint between these two numbers. I do that by adding them together and then dividing by 2. Once you find one class boundary, the rest are easy. Just keep adding the class width and subtracting the class width. You can also find the class midpoints by doing the same procedure. It may come in handy when we start plotting these guys.